The Science Basement!
Hello and welcome to the Science Basement podcast, a podcast for people who love all things science. I am your host Sujay, and today we are kicking off the first episode of season 5 for the year 2025. Last year you guys showed a lot of love, all the listeners, so we are really grateful for that. And this year we just thought that maybe we'll start an episode with an in-house production without calling anyone from outside. And today I'm joined by members of the Science Basement podcast team, and I think my co-hosts will introduce themselves now. So, hi.
So hey, I'm Emmy. I just recently started as one of the hosts here in the Science Basement podcast.
And you are one episode old now.
Yes,
Right?
yes.
Yes.
So I'm soon to be a podcast host toddler, maybe.
Congratulations.
That's great. And so which department are you in?
I'm in
what's your PhD program?
I'm in the doctoral program for wildlife biology, so Luova, also known as.
Oh, okay.
Yeah.
And you are in the Wiki campus?
Yes, I'm from the Vik campus.
And Uka?
Yes, hello. I am Oka from the master's program in urban studies and planning at the University of Helsinki. I'm almost everywhere, and in the podcast team I'm still figuring out and in the observation phase now.
And you joined the master's program, like just, you've been here for some time now in Helsinki? Or?
It's my second year of the master's degree.
Cool. So there are at least 2 people who have spent 2 years now in Helsinki.
Yeah.
I've been here for 2 years as well. And, I just forgot, I think I should introduce myself as well. I'm Sujay. I'm a second year PhD student in the Institute for Atmospheric and Earth System Research, as well as the Department of Physics in the Faculty of Science. I know that's quite long, but that's the full name of my department. It's just a long name. So today's episode, we guys are going to be talking about the studies, scientific studies that interested us last year in 2024, and the breakthroughs in science that we are excited about actually this year, the upcoming things, So Emmy, was there any study that really intrigued you last year?
Well, there was this one study which is not directly related to my own research in any way, but it's about bumblebees and social learning of
Nice.
bumblebees. So I found it really cool that they actually started the paper with the concept of culture and how culture is defined as behaviors that are learned socially and that persist over time, and how culture is usually something that people have conceived to be something uniquely human. But actually now we start to get more and more evidence of actually culture existing in different species of animals as well, which I think is not actually surprising in any way. But so in this study, they looked at social learning in bumblebees. They had this kind of puzzle box for the bumblebees. So this kind of contraption where the bumblebee has to kind of push 2 different obstacles from its way in a specific way to get this kind of sucrose treat eventually. So they had bees that they trained to learn how to get the sucrose treat. And what I found really cute was that they called these bees the demonstrators. And then they had bees that had never seen this puzzle box before. And then they were allowed to watch the demonstrators do the task of getting the sucrose. And actually they found that out of these 15 pairs that they had,
Okay.
in 5 of these cases, the observer learned the quite complex behavior from the demonstrator.
Oh,
Yeah.
that's nice.
Yeah, and none of the control group. So they also had these bees that have not observed any other bee do the task. And then they let those bees just like in isolation just explore the puzzle box. And none of these learned the task. So it was something that they needed someone to teach. And and that was really cool.
Oh, okay. So there's almost like a
Yeah.
whole education system there.
Yeah.
So the bees who are observing are kind of the younger bees, or who have the another
I think-
responsibility and becoming the demonstrator. Or?
Yeah, I don't think there's any like age separation or anything like that. They just like one of the groups was trained for the task and one was not. Also, what I found quite funny about it was that because there were these 2 obstacles that the bee had to push on the way to the sucrose treat, and in the training phase, the researchers noticed that they needed one treat in between of those two obstacles because otherwise the bees would just like get frustrated and give up. So they needed like a little pick me up in between. And I'm like, this is something that actually I could use in my own life. If you have like a difficult task, like split it up and then give yourself a little sucrose treat in between.
That's exactly true. Okay, that's good.
This is really interesting, and I mean, even in our episode last season in High Life episode 2, I think Katya talked about similar sort of organizational behavior in birds.
Yeah.
So now, I mean, we clearly see, I mean, chimpanzees also show same kind of like, organizational behavior. So this is kind of really interesting that even bees have this.
Yeah.
Exactly. Like, I had this kind of listen to one podcast about human species are not the greatest species of all kind, but actually those animals that can't speak might have even greater culture than we even have. So I think that bees are kind of one example that
and it's really cool because they have such a simple nervous system, but yet they can learn these really complex tasks, and they're very social, and
they might even speak with each other and kind of like communicating with each other in kind of the language that a human cannot understand.
No, absolutely. And even things like, I mean, obviously there are animals who can show high IQ, a lot of the apes and stuff. Or even bees for that matter. I mean, this is certainly high IQ really, the kind of stuff that they're learning and in some sense.
Yeah.
But then you also have, I mean, dogs are a good example of, high EQ, high emotional quotient. I mean, I don't know if they can do advanced math like the chimps can, but but they do understand when distress in human beings and stuff. That's why they're used for people who have PTSD and things like that.
True.
I mean, emotional support and therapy dogs, I mean, they certainly have a kind of heightened sense of, for lack of a better word, empathy maybe. So
I also heard like a very interesting another podcast about whales. Like, why do whales will never lose you? Like, will they have 100% chance that they will catch you? Was that they have a very good electricity receptor in their kind of mouth facial area that they receive like even your small heartbeat, like few 100 kilometers away, might be not 100 kilometers, but few kilometers away, they will still like receive your electric kind of motions or the heartbeat from them, and then they will like probably like most definitely catch you and
that's comforting.
And I mean, orcas are also part of the whale family, so it's clearly they can do pretty complex things. I mean, I think now obviously they are banned in circuses and stuff. In
which
probably
is
most
great.
countries across the world. But I mean, any animal which has been historically used for like entertainment acts in circuses and stuff, they definitely have some amount of like intelligence quotient, because to know and learn tricks requires intelligence, and we've come a long way. I mean, since Charles Darwin, really, in that sense. The thought was that animals maybe are, when you talk about sentient beings, humans and animals, humans show intelligence and animals are not really intelligent in that sense, in the same way humans are. But now slowly, I mean, as more and more scientific studies go, people see that, there are aspects of intelligence that are displayed by animals and birds and insects. So it's actually a very, very cool study.
And even sometimes my cat looks like she's almost becoming a human.
I had a dog. He is now passed, but I always said that if he just started speaking to me in Finnish one day, like I wouldn't be surprised. Like he seemed like he was a human in dog costume. He was very smart.
Yeah, exactly. Like sometimes my cat looks at me like my mom or some human being. Okay.
Oh yeah, Emmy, I think you forgot to mention the authors of your paper if somebody really wants to go through the same study.
Oh, yeah. Sorry, good point. So the Bumblebee paper was by Alice Bridges et al. And it was published in Nature in 2024. So I think that will help you find the paper for those who are interested.
And that was a paper in the Nature journal.
Yes.
Oh.
I think it was in Nature.
Okay.
Yeah.
We scientists, every time you hear a paper in Nature, your ears just perk up.
Yeah. Yeah.
So, Uka, what about you? I mean, what study really interested you last year, which you are excited to talk about?
I want to start it with my personal story. Actually, I attended kind of a virtual exchange program with University of Helsinki and several universities in Ukraine last year, a few months ago, and it was a climate university, like climate and sustainability courses on there. And on the first day of that program, there was that siren sound in one of the towns in Ukraine. And then in the common Zoom chat, one student saying there's siren and we have to move to the shelter. And then the next few days, the siren sound was not only in that town, but it was like almost all over Ukraine. And there was that kind of the small teams that we have divided, and then it have to be actually 10 of us in the beginning, but at the last it was only me and the moderators, and all the other Ukrainian students could not attend because of the thing. So that kind of triggered me to be interested in Ukraine, and then we discussed a lot about sustainability, more like a global sustainability, and I wasn't expecting those Ukrainian students to even consider sustainability while
I was going to say that.
Yeah, exactly. Like while they are having very difficult situation in the shelter.
Like in these times,
Yeah, true. But they were actually very considerate about the sustainability during the war and even after the war. So I was like, oh my God, that's kind of very interesting. And I have to read at least more about sustainability in Ukraine. And I found this article, which was published July 2024 by Yevgenia Kopitya. She was a postdoctoral researcher in University of Oxford, and the article was The Russian War Against Ukraine, a case study in climate conflict and green recovery. So she was starting this article with war as an opportunity. That was kind of the shift, very bright, optimistic start of the article, I would say, compared with my experience of the previous exchange program. So she was even claiming that Ukraine can be a leader in energy sustainability. And I was like, oh, okay, let's proceed. That's interesting. Yeah, so she started it with kind of how many environmental damage in US dollars would you expect that this Ukrainian war has produced? Can you expect?
Okay, you want me to put a dollar amount on
the economic damage.
Economic damage.
In monetary.
It's really difficult, but I'll take a
million or billion or...
I think it's going to be in billion, certainly. It's going to be not in millions, but in billions.
It's going to be huge, I would.
But 10 billion maybe? I don't know.
10 billion? Yeah. That's 5 times more. than 10 billion. It's
Oh.
actually $56 billion
Okay.
dollars of environmental damage, which is almost
Wow.
17% of GDP of Finland. That
My
was
God.
quite shocking. And even the recovery cost was almost 500 billion
Wow.
USD.
I have to make a perhaps a silly question, but how does kind of measuring environmental damage in dollars work? Like, what is this?
So I
metric?
suppose this amount of damage in monetary form was counted in how much damage it cost to the infrastructure, the manufacturers, the buildings. So the buildings have the property value, infrastructure.
Okay.
Kind of property value, and there's that kind of the life cycle of those buildings.
Oh yeah. Like human built environment. Yes.
Human built environment and the cost and the carbon emissions it cost to build those things, and then destruction.
Yeah.
Carbon, like the carbon emission, and then recovery cost. That's kind of how it's usually calculated, the damage.
Okay.
Yeah. So it produced also 175 million tons of CO2 equivalent, which is almost 4 times than annual CO2 production in Finland.
Wow.
But then Finland is a
That's-
very sustainable country also.
Yeah, that's true, but still,
Yeah. It's a lot.
But
still
it
that's
is a
quite a
lot.
lot.
Yeah.
Obviously, we can't emphasize it more that it's this
Yeah.
war is really
Yeah.
it's not just bleeding Ukraine, it's bleeding the entire world in some way.
Yeah, Finland is actually performed the highest in SDG performance in 2023.
Oh, okay. The Sustainable Development Goals.
Yeah.
Oh, okay.
The highest index in sustainable
Okay.
development
Nice
goal.
to know. I didn't know that.
Yeah, so you
Yeah.
are doing quite great in sustainability, actually. Yeah, that was kind of one of the reasons why I chose to study here in Finland.
Aw.
Like those kind of sustainability indexes, human development indexes, livability, happiness indexes, all attract international students like
Yeah.
a lot. So
Yeah, I mean, just as you said, this was one of the reasons you chose Finland to study. It was kind of similar for me because I remember talking to someone in India and they're like, "Oh, why are you studying air quality in Finland? Don't they have good air anyway?" I was like, yeah, that's precisely the reason, because you need really clean environments for to check the efficacy of your instruments. Because even badly calibrated instruments can give you
true.
measurement, readings in highly polluted environments. But how good an instrument is, you really get to know when it can measure low concentrations. Because that tells you that, like the level of detection is really high. It can really, really measure minimal concentration of whatever pollutant that you're trying to measure. So in my case, I'm trying to measure pollutants in the air or aerosol concentrations in the air. So it's one of the reasons. Even though Finland has like really amazing air quality, it's also a really good place for aerosol science research. So, yeah.
interesting
But
to know.
yeah, this work is really interesting, and I know a couple of people even in my department who are trying to quantify black carbon emissions and those sort of things from not in my department really, but in my discipline, let's say, who are trying to do this research of the impacts, the atmospheric impacts of the war in Ukraine. Because certainly when you look at black carbon concentrations, there is a spike. So, which is indicative of the bombs and all those other things.
Yeah, that kind of explains also why those 175 million carbon emissions.
Exactly.
Yeah.
And black carbon affects everything. It affects human health. It affects agriculture. So the impacts are really manifold.
Okay, so if we go back to the
Yeah.
Okay, so of course, this amount of destruction would cost a lot of recovery and reconstruction, and even in this situation, they already started thinking of how to reconstruct Ukraine in a sustainable way. So that would, of course, need energy efficiency, a lot of renewable energy. So the author was claiming that Ukraine is even trying to use renewable energy and electronic kind of technology in even in the war as a war technology.
Okay.
That was kind of shocking to hear. Like, the author was criticizing how Russia is using all those kind of non-renewable energy in war, while they are using electronic drones and electronic motorcycles.
It would be kind of surprising to me if they did use like sustainable energy in war, because war,
I mean, given the natural reserves they have also.
That's true. But also like the nature of war, like it's quite
exactly.
amazing if someone actually starts to think about like sustainability.
Yeah, in that
within it,
situation.
But also I think it's kind of really cool and interesting that someone is so optimistic that they kind of jump to, okay, we have to now rebuild a country. Like, how do we rebuild it? And with what kind of resources, and how can we make it more sustainable? That's really
exactly. That's true. Like, while I was reading this article, I was like, oh, okay.
Yeah.
So she and they are already thinking of this renewable energy in reconstructing while we are still in a peaceful country and like struggling a lot to transition into clean energy.
Yeah, exactly. Yeah.
Yeah, that was kind of interesting. And she was criticizing international agreements in countries that even though Ukraine is trying to transition into clean, sustainable energy, the countries with even developed countries like Canada, America, are not transitioning completely into low carbon energy. Like, they are still using fossil fuels, and they are still like opening new mines. So that was also
things
kind
have
of
just gone worse since January 20th, as transfer of power has happened in the US, because they have signed out of the Paris Agreement also, and
exactly.
the next couple of years are going to be really difficult. I mean, I think I'm not even saying something which is politically very, controversial at this point. Like, I think the world's made it's really disheartening that the world has made its peace with the issue of, there's no outrage about the fact that US has pulled out of the Paris Agreement. And what happens is, when obviously countries such as the US pull out of these agreements, it sets even Europe, which is pretty good on environmental issues. I mean, it just breaks the morale of the entire summit, of all the COP meetings that keep happening every year, because the transfer of power or the transfer of rather technology and these sort of things have to happen from Europe and the US to the global south and other developing countries, which is taken a beating, obviously. I don't know how much can be done now, but these are really trying times for people working, in the earth sciences and sustainability in general.
Yeah, the author also criticized that this Paris Agreement now is far from being achieved by 2030, actually. Like, it's quite difficult now to achieve that 2 Celsius degrees with this pace. And now that a lot of countries are pulling out of this Paris Agreement, like informally and formally.
Yeah, true. And there's also, I remember reading James Hansen. He's an American scientist, and now I think retired, but even he's still pretty active in terms of activism, and I think he's 90 years old or something, still writing papers. So quite a guy. And I mean, back in the day, in the late 80s and early 90s, when climate change was just becoming, a newsworthy issue that, he gave, I think, one of the first Senate hearings about, that, hey, climate change is real and the US needs to do something about it. I think 1988 or something. And so he recently said that it's almost certain that we are not going to be able to achieve the Paris Agreement in the stipulated time. I mean, a lot of people are accusing him of saying things like, oh, don't say that, because once you say it, then, people will stop even trying and stuff.
Yeah.
But
I
but
get
that's
that point too, but then also
Yeah. I mean,
the truth is
the truth is the truth. I mean, somebody see, you can take this news both ways. You can say, oh, if we are anyway just under the bus, let's not do anything. Or you can be like, okay, no, we need to act even faster.
Yeah.
So that's the thing. So I'm not for climate doomism, because I think doomism doesn't really help. You need to
I
do
think
something.
it paralyzes people in
It
a way.
paralyzes people, and that's not helpful really.
Yeah.
So but also one needs to know how fast we need to act.
Yeah.
So
And I think it's kind of important also to wake people up, like in like, hey, there's actually a problem that we need to do something about, like now,
Right,
like
right,
yesterday.
right.
Yeah. And even more faster than we should have yesterday.
Yeah.
Right.
2 times faster than yesterday. So Ukraine is being actually very optimistic and wanting to achieve net zero emissions by phasing out coal by 2035. And surely they need great amount of funding. And then the author highlighted that currently the international climate funding system is not actually working for countries like Ukraine, because it was actually drafted or approved almost 3 decades ago, quite outdated. And then Ukraine was one of the developed countries before this war happened, and then showing a good economic growth. And actually, there is that United Nations Framework Convention on Climate Change, and there is that like the country categories that Ukraine used to be in the Annex 1, which is like the more developed countries, and now even Ukraine is still in Annex 1, the developed country kind of category. The GDP, of course, has dropped dramatically, and then with this kind of the GDP and economic downfall, Ukraine do not have, with this great destruction and great amount of investment they need, they do not see any possibility of funding themselves. But actually, because they are like in the convention, they are still developed, categorized as Annex 1, then they cannot seek for international funding, because that funding is for the least developed countries or the countries in more kind of attention. So this current international climate funding system is not actually working for Ukraine or any other countries which are having these political problems. So Ukraine is seeking EU membership and wants to push the EU members to support them. And pushing for accelerated energy transition together. So they see actually this EU membership as a pathway to kind of earning a lot of funding, because now the current international funding is not really working for them. So that's kind of the situation in Ukraine. But I find this article quite strategic, I would say, instead of like a scientific article or something, because it's kind of like the tone of writing was more like seeking or like encouraging the international donors or the projects to consider Ukraine and see that we have like this amount of problem, and then but we still believe that we can be a good example of how in those kind of difficult situation a country can actually become a leader in energy transition and start everything from anew. So I think that was quite a strategic paper that it was also interesting that the scientists in those kind of how the writing tones and how they write, the scientists write their papers in those kind of countries are affected by their country situation was very evident from this article. So
because science does not happen in a vacuum.
Yeah,
so there is
exactly.
obviously a sociological background to the science that we do also. Like I'm sure these days with advances in AI and stuff, even in the life sciences, if you write a grant and you don't have the buzzword of AI, your funding chances get sort of reduced quite a bit and stuff. So everybody's, you have these buzzwords in every discipline. Cancer is another one of them, which is, any grant that you're writing for Academy of Finland or any other grant. Similarly, even in India, I mean, Department of Science Technology, DST grants and stuff. You obviously have to, so climate change, AI, cancer, these are all things that, unless these things are there in your proposal, things just don't get funded. Or get less funding.
True.
So in conclusion, of course, Ukraine is facing a lot of need for great amount of investment and effort in everything. So let's see how Ukraine will do in the future and wish them good luck.
Let's see how this year goes. And this year's gonna, because the war has really, really dragged long. Loss of so much of manpower and money is,
exactly.
How long can a country really sustain itself,
That would definitely take a long time.
Exactly. So, that's really nice. I mean, we took a bit of a detour into, I would say, the social sciences with your work, which is great. Because we actually haven't had a lot of people talk about social sciences really on the science basement so far. And it's nice that, you brought a different sort of lens to look at the world.
It's good to hear.
Absolutely. And in fact, your work is, the paper that you presented is really at the intersection of, I would say, like science and pure science and social sciences.
Yeah, pure and a bit of political.
And a bit of policy. So it's actually, it's a pretty interdisciplinary work.
Sure.
Well, I even have an interesting study that was published in 2024 by these two people, Eyal Frank and Anand Sudarshan. I think this paper comes from University of Chicago. And I think Anand is somewhere in the UK. I don't really know where. But the paper is really interesting. It's about the social costs of keystone species collapse. Evidence from the decline of vultures in India. So this is a really interesting study. It was published in the American Economic Review. And when I first read the study, I was like, hold on. I mean, is this really? I mean, how can this even happen? So in short, what this study did was that it calculated the economic loss due to the disappearance of vultures from India. And I mean, what if I told you that like the disappearance of vultures from India has led to a 4% increase in human deaths and an economic loss of nearly, wait for it, 69.4 billion per year.
Oh my God. Wow.
But this is what happened. And the culprit in this entire story is really a painkiller. Like your Burana or your ibuprofen that you have when you have a headache. So literally there's this painkiller which is called diclofenac. And this painkiller is an NSAID. So you'll have to correct me here, you're the biology person. It's a non-steroidal anti-inflammatory drug. Yeah, I think I got it right. NSAID.
I have no idea. I have trust in you.
So this is like a general, all your over-the-counter OTC medicines are generally NSAIDs or NSAIDs. And diclofenac is also, I don't know whether diclofenac is over-the-counter, but it's certainly an NSAID, and more for veterinary purposes than human. But also, I mean, humans can take diclofenac. It's not that humans can't take it for pain. So, however, what happened is that this was widely used for veterinary purposes. So cows and cattle in general and stuff. And now, as you know, that vultures are scavengers. So they do feed on the dead carcasses of cattle. So this is basically how diclofenac, which was widely used in India in cattle, entered the body, the bloodstream of these vultures who were feeding on these carcasses of the cattle. And this drug ultimately, when inside the body of vultures, basically caused kidney failure in vultures. And that led to a rapid decline of the raptor population. Vultures are raptors, basically. So just led to like a sudden decline. And what happens is when the scavengers in an ecosystem die, that leads to basically all kind of, it's like a public health problem then, because the decomposers are not really doing their job. And they basically, like, this led to a rise of feral dogs and disease. I mean, I'm also a big fan of dogs, but feral dogs are different than, your pet Labrador. So, with fewer vultures to clean up carcasses, there were stray dogs and rats. Their population kind of increased and led to more cases of rabies, anthrax, other deadly diseases, which spread to humans. So, this way, I think I can't go. I mean, I didn't really understand the economic methods or the heavy math that they did. But the researchers in this paper estimated that India saw a 4% increase in human deaths, just which was directly
4%
attributable to vulture population decline. And then obviously the ensuing economic chaos, I mean, was like, I think the math they did said that it was about 69.4 billion in damages. And
billion
USD, billion with a B, not USD.
Okay.
USD.
Billion USD. Oh my God, that's a lot.
A lot of money.
Yeah.
So, how much was the decline that you said, economic decline in Ukraine? That was about 50 something, right?
56 billion
56
for
billion.
environmental damage.
What to do? Large country, large population.
Yeah, exactly.
So that's what, right? Exactly. I mean, just to give a comparison, this is like 69.4. I mean, even if you account for all the uncertainty and things like that, it's quite a bit. And it's pretty crazy to think that, birds' disappearance could lead to, shake an economy to this extent. So, I mean, this is basically because the government has had to spend more on carcass disposal, medical treatments, rabies control programs, and, farmers also, farmer support and things like that. So, I think I'll just briefly explain what a keystone species is also, because I've been talking a bit about keystone species. So, keystone species is basically a species that's like so important to the ecosystem that when it disappears, the entire ecosystem starts collapsing. I can give you another example. Elephants in India are also, at least in southern India, are considered to be a keystone species.
Okay.
The moment you see a decline in elephant population, you know that, things are bad. So, well, I mean, right now they are trying to do conservation efforts and stuff with vulture breeding programs and all sorts. But the problem with vultures is that they don't breed like rabbits. So, breeding programs are like really, really difficult. They are, in that sense, a bit like pandas. Because like China, I remember a couple of years ago, like really went, took some really stringent measures to get their panda population under control. Now, I mean, obviously they've been pretty successful, but it takes a lot of government intervention, time, money, energy, everything to revive a lost population of.
And even then, like, this is probably going to have like genetic consequences, like maybe because if the species is kind of brought back from the brink of extinction,
right,
like.
Right. But that's interesting. I mean, you work on genetics and stuff. What could be the implications really? Because this paper, I don't think has touched on the science at all.
Well, there could be, for example, if there's inbreeding. Okay, this is going to be very population genetic-y.
Okay.
But so if you have if you have a large population, and we have 2 copies of each allele, each genomic loci, and there can be these variants that are harmful, but if you only have 1 copy of the harmful allele, you're fine. And if you have a large population, then it's quite likely that you might have this sort of variants, but you don't really see the effects because you get like fresh gene flow and exchange. But then if you have a small population, then these variants can start to accumulate on the same individuals. So then these homozygote individuals, so the ones with 2 copies of these variants, then they might start having some sort of health issues, for example, and then that might affect the health of the population. But we shall see how it goes with the vultures.
Right.
Yeah.
Can they even contribute to more mutations?
Not necessarily. Well, actually, in a way, yes. Because we also know that in small populations, natural selection does not work as efficiently. So then this also means that there might be these variants that occur by chance, and then they are not kind of cleaned away from the population. And then there might be this like accumulation of some variation that is not useful for the population. It might not be harmful either, but...
Okay, so there's still a small chance that if that thing really happened, then we might see reptiles with 5 legs or 2 tails.
Yeah, that's a bit dramatic, but yeah. But let's hope that doesn't happen. Their breeding program might be very successful.
Yeah, exactly.
But there might be some consequences, of course. Yeah.
Yeah. Okay, let's wish for the best.
Yeah.
So Emmy, what about any scientific advancements that you're looking forward to in 2025? Or it could be anything, a conference or something that you're looking forward to. Doesn't really have to be a paper again, a research paper.
Yeah, there's actually this next summer, this evolutionary biology conference that I'm planning to apply for a talk in. So yeah, thank you. If I get a talk there or a poster, like it would be my first international conference.
Yay.
Yeah.
And does your program have like a requirement that you need to present at least like 1 international talk or 2 talks or something? Because I think it's a requirement in my department, you at least have to give 1 international talk outside Finland. But
I'm actually not sure. We might have
a
requirement, but I'm not quite sure.
Okay, anyways, good luck with that.
Thank you.
Yeah, that's great. And Uka, anything you're looking forward to?
The biggest thing I'm looking forward in this year is my thesis, master's thesis. Yeah. I'm actually
back some painful memories.
Yeah. This kind of the sustainability is quite the main kind of umbrella term for my thesis, but I'm more specifically working on urban energy governance in Helsinki and how cities can steer sustainability. Only the energy is kind of the specific field I'm working on because sustainability is quite big. Yeah, so I hope for the best.
Nice.
And how about you?
So, in terms of conferences, I don't really know right now because I have not applied for funding or anything for any conference right now. I'm just trying to get my first author article into publication. So I'm just really pushing hard at that. And I gave a talk last year in France in an international conference. So I'm just waiting if this paper sort of goes in, at least even if it doesn't get published, but at least is in press. Then because I've already missed the deadlines for most European talks, conferences. But we also have this, the American Geophysical Union, which is a huge conference of almost 20,000 scientists that happens usually in San Francisco, but it can change. And it's I don't even know, this year with the new administration, it'll be interesting to see what happens. But yeah, it's gonna happen. And if that's one of the conferences I'm really looking forward to. I hope I can go there and present something.
Cool.
Also, climate-wise, this year has been quite disastrous. I mean, California wildfires.
Yeah.
The year started on a rather grim note. And there is one kind of work that I'm really looking forward to, which is there is a new climate model that Microsoft Research has they've published a paper about it. It's called Aurora. And it's a AI-driven foundational model for modeling the Earth system. And I mean, obviously we've had numerical weather prediction with climate models for quite some time now. So the most basic models kind of came up in the 1960s when, with the advent of computation and stuff.
Yeah,
Before that,
yeah.
you literally had people doing, math by hand, and more statistical techniques were used. But people didn't really understand so much of the physics, or even if they did understand the physics, it wasn't really applied for weather prediction and stuff. But with the advent of computing and supercomputing and more computational power, climate science has moved in that direction, and it's kind of become like a subsection of the computer sciences and physics department, really. So, in fact, the person who really developed the most basic models back in the 60s and led to its development in the form that we know now today, got the Nobel Prize, I think, a couple of years ago. He's still alive, Japanese person.
Okay.
Sukaro Manabe.
Japanese leaves quite long.
Yeah.
So, that happened a couple of years ago. He's still kicking strong. And still very much, publishing stuff and
Okay. Yeah.
he's,
That's cool.
he's an emeritus professor at Princeton. So, but yeah, this work, Aurora, I mean, they're training millions and millions of hours of data and fine tuning it for specific forecasting tasks. And I think it's capable of doing air quality forecasting, wave prediction, cyclone tracking. So a lot of stuff. In fact, it outperforms numerical models in 92% of the cases in weather forecasting. So weather forecasting is something that is very tricky. And climate forecasting, because you're looking at general trends, there is more room for uncertainty and stuff. But with weather, it's a different beast altogether, because you have to predict things on much shorter time frames. So,
But how do you forecast weather before this tech area?
You obviously have a lot of historical data to sort of train your models and stuff. So that is one of the things. And it's not
Even
purely
before the computers, how do you...
before
How
the
does people
computers and
forecast?
stuff, obviously, I mean, I think most of this weather modeling would have been statistical in nature. But I don't want to go into really complex science. But at a very basic level, what happens is that if you use statistical, the weather system is a chaotic system.
Yeah.
Okay, and
Okay.
so I don't
Big
want to go into
data.
chaotic. Yeah. So the point is that just no matter what kind of stochastic random modeling or something you do, you'll never be able to very accurately predict the weather. It's just impossible, even if you have all the computation power in the world. That's the nature. So another example of a chaotic system or a stochastic system would be the financial markets.
Yeah.
They are also
Yeah,
similar.
true.
Yes.
That's
So
very unpredictable.
It's very, very
Yeah.
difficult to. You can make useful predictions that are, but it's very difficult because it's not a deterministic system. So you can never just predict it with pinpoint 100% accuracy. You can just, do some predictions with high levels of uncertainty. And sometimes, I mean, if you can just get these predictions into a reasonable level of uncertainty, you're good to go, essentially. So that's where we are at. But with improvements in AI, I think this weather prediction capability can improve. I mean, as they claim that it's outperforming traditional models, climate models, in 92% of the cases. So let's see where this goes. I mean, I am really worried that it can, advances in AI in climate. I'm excited and worried at the same time because this essentially can eat up my job. So
Nervous laugh.
this is so. But again, I mean, humans. I mean, we'll all only benefit, I hope, in the future because we'll also change our skills and upskill ourselves in a way.
Yeah,
that,
exactly. It's kind of very interesting that now if you just type few words, then you can generate a city. But back then, only 100 years ago, how the urban planners and architects plan the cities was like they have the very long paper on the floor and then draw the whole city by their hand. But now AI is producing
you have
a
GIS
whole
programs
city.
and things like that.
Yeah.
So, Google Earth and all these things and
very fancy,
virtual
nice
maps.
softwares that we can use.
Yeah.
And now with this even AI, then
Right.
we can just say to our computers and then it generates any type of cities that we want. So
No,
it's,
absolutely. I mean, even with weather forecasts, I remember like in the 30 odd years that I've been on the planet, things have become much, much better. I mean, I remember like as a 5-year-old and stuff, and people like my dad, just reading the newspaper at the breakfast table and being like, oh, the paper says that it's going to rain today. I'm pretty certain it's not going to rain. That was the Met department was really, really infamous for bad predictions back in the day. But not anymore. I mean, these days, my father is like, keeps telling me, oh, just look at, your iPhone, just check the weather and stuff. And I'm like, really? I mean, you weren't really confident on our Met department skills 2 decades ago. And so predictions have become really, really good. And even in Finland, I mean, because I do work, my advisor is currently employed at FMI. So here predictions have been very accurate. And even in India, predictions have now become quite good. Yeah, beat air quality or beat rainfall, precipitation. And now we have a lot more indices also. We have this app that tells you that heat stress index and all sorts of things. Because sometimes even like just high temperature doesn't really mean that the heat stresses a lot, because the heat stress becomes a lot more when you have high temperature accompanied by high humidity.
Yeah.
Because you sweat more, and so dry heat doesn't really do you much damage. But humidity and high heat is the real killer.
Yeah. Yeah.
okay,
So-
I have a question
Yeah.
for you. Does population number affect the accuracy of the simulation?
Population
Or not
number,
really?
I don't really know whether that's actually a good question. I actually have no idea whether population density is taken into account in climate models.
Yeah.
Because I am not really a climate modeler. I work more on like long-term trends and like statistical analysis of aerosols. So that's basically my research area. But that's a very legitimate question. I don't really know. It probably would make some I would assume maybe some statistically significant difference. So yeah, with this, I mean, it was great that we really discussed a lot of science in this episode. And with this, we come to the end of the first episode of season 5. I hope you've enjoyed, and it's been a long episode, but I hope you enjoyed this episode with us. Please do not forget to subscribe to the Science Basement podcast and listen, share, subscribe, and share our episodes with your friends and family. We are all on your favorite podcast platforms such as SoundCloud, Spotify, and Apple Podcasts. For the past episodes, you can also check out our website, thesciencebasement.org. And thank you everyone for listening. Until next time, take care and bye.
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 The Science Basement.